Hey everybody, this is Larry. This is me doing the weekly premium challenge, week 2 of the July premium weekly something challenge. I don't know what I'm saying anymore. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this poem. And we have a treat today, and I say that because I have not solved this poem yet. Yay! Alright, 285 in order successor in BST. Given the root of a binary search tree of P, return the in order successor of that node in BST. Isn't that straightforward, or am I misunderstanding it? Given a node, you have to find the node first, right? They give you the node? Okay, they give you the node. The input here reading it is just awkward. Oh, I guess it's not necessarily. For root, then yeah. But here, for example, the next in order successor would be a 5, right? But I don't know. I mean, I think I'm just trying to be a little bit smarter, in a sense. What I mean by that is that otherwise, like, I mean, we could do the linear thing, right? Like, I think there's no, like, we just go through the entire list. There's nothing tricky about it. The only thing that's a little bit tricky for this one is that, yeah, if you have access to the parent node, then maybe this would be easier. Easier as in like computationally easier, but I don't know how you can do it without looking the entire thing, right? It's okay because you still have to find the node in the tree, so that's going to be linear time anyway. Like to get the parent, like you have to find the node to be able to get the parent, and that's going to be linear time. So I don't think you could do better than that. Maybe I'm wrong. No, I am wrong. So you could find the parent. Wait, no, it is still linear time. I was going to say maybe you could find the parent in log n time because this is a binary search tree. So you could find the node in log n time instead of linear time, right? But that's not necessarily true because it's not a balanced binary search tree. It's just a binary search tree. And the distinction is that you could see an example, right? You have a linked list. So then in that case, it's still going to be linear time in the worst case. But we can make the average case a little bit better for sure, right? Because here, and did I say 6? But I meant 5. It's just going to be one of the, so, yeah, so then maybe I would have something like if p dot right is not none. Oh, sorry. Yeah, if p dot right, because on the left side, it doesn't, you know, like it by definition is smaller. So b right is not none. Then we want to it's the next smallest value, which is going to be on order on the left as much as we can, right? So current is equal to p dot right, while current is not none. Current is equal to current dot left, and then at the end, current is none. So I messed up. There we go. Not legs left. While current, so then now current dot left is none, so then we can return current, right? Otherwise, then we have to find this node, and it's going to be the, I want to say, yeah, I mean, it is just a tree, right? I mean, we have to search for it. So then we have, are all the values unique or distinct? Okay, there you are. So that means that we can binary search for it easily. And that is that. Okay, so current is equal to root, right? If while current dot value is not equal to p dot value, if that's not the case, then what happens? Then now, if current dot value is greater than p dot value, then it's on the left side. So current is equal to current dot left, right? But I don't want to do it this way. Or I mean, maybe I do, but this is a little bit awkward because we don't want, because this will find as p, but we want the parent of, in fact, okay, actually that's fine. Maybe we don't even want it that way. We just, let's call it an explicit stack, right? It's equal to current. Maybe that's fine then, because I think maybe you need it anyway. Well, no, actually, okay. Let's go for it. If the current value is greater than this, then we update. But also that means that possible is equal to current, right? Before we update it, because then now I think this is fine. Because if you kind of think about the invariant, every time we go left, that means that the root node, the current root node of the subtree is bigger than p.value, the search node that we're searching for. So then it is going to be, yeah, this way, right? And then else, if it's bigger, then just current is equal to current.right. Yeah, and I think that's it. And then at the end, we just return possible, maybe? Yeah, because by definition, by the invariant, we already checked that p sub right is none. So that means that when we see it, this should be good, maybe? Is that or I'm off by 1? Let's give it YOLO submit. Maybe I missed an edge case. But, okay, that turned out pretty okay. Yeah, so this is still going to be worst case linear, right? Because you could imagine a degenerate binary search tree where it is just a linked list, right? Everything's to the left or everything's to the right or something like that. And it would, you know, yeah, linear time, linear space. But on average case, it should be much faster, and we're happy with that. Yeah, huh. Apparently Bill did even better. Am I silly? That's crazy. I don't know how you can do better. I'm just curious. I'm actually now very curious. I mean, I know maybe it's constant cost, but I don't know how you can optimize this that much more the way that I did. I mean, I literally just go left and right, and there's no parent. Huh. I think the idea is going to be right. Did I miss an idea? Without using it? Okay. I mean, yeah, this is going to be linear time because the, you know, okay, yeah, that's what we're saying. Using BST properties. I mean, that's basically what we did here. So, I mean, I didn't think of it quite the same way, but yeah, it's the same thing though. Yeah, so I don't know why my code isn't that slow, but I don't know. It's fine. I am curious, but it is interesting. I guess recursion is better. I don't know. This is very weird. But there is only like much slightly smaller, so maybe that's why. I don't know what this is going on. All right. Anyway, though, that is all I have for this one. Let me know what you think. Thanks for watching. It is linear time, constant space, and yeah. Thanks for watching. Stay good. Stay healthy to your mental health. I'll see y'all later and take care. Bye bye.